No, no, I think it's fine. Basically, we let's go and share slides. Oh, it just does it. Yeah. Okay. So what if I share below the slides? Hold on. Yeah.
Oh, wait, wait,
It's fine. Ah, okay. It just IT share slides. Okay. So it's basically yeah. We can open a separate window.
okay. Feels a bit different. Let's see if it's fine enough.
Okay. Fine.
So we are already at the top of the hour. We have 2 hour schedules for this meeting. The slide deck should be visible. It is not visible to me right now. It is showing up to you.
Yes. Look, it's in front of you.
Oh, oh yeah, and then I put this. I can't. I have to do this. Ah, now I can see them. Wonderful.
But I assume. Oh, okay. Yeah, I can control it. It's fine.
Yeah, let's do this in this things. So first of all, welcome everybody. This is the fourth day of the IETF 113 in Vienna hybrid meeting. Very astonishing that we are doing this in hybrid actually. Let me, and I speak also loud, put on my mask because that's the thing we do here. So your lovely co-hosts, co-chairs are Alexei next to me and me, I'm Hank. And first of all, please mind, this is a recorded session because this is an IETF event. Okay, yeah, I hope everybody is now well, as Lars said it with the unreadable note well. There's a lot of things in here. I think most apparently, please read BCP 54 and 78 and 79. It's a code of conduct, and whatever you say here basically can go into the IETF Society's IPR pool. So there's a note here about information. Also, I think important to highlight is BCP 25. I think it's kind of obvious, but I want to restate, be nice if you want to be treated nice. I think that hasn't been a big problem here, but you don't never know what happens in the background. Thank you. And so that's about BCP 25. Next slide. So yeah, this is a hybrid meeting. In-person participants should raise their hand with a tool. So if you have a device with you and you can join the Meet Echo, you can get in line because there are now virtually two lines. You have the physical in line and the actual line. It makes more sense for us if you raise your hand so we can see the sequence between virtual people going into the mic and the physical attendees going to the mic. So that really helps us, but we will also try to track off people who can't raise their hand in the room here. So anyone who is not actually participating in discussion is advised to mute their mic. I'm not so strongly averse at seeing everybody, but if there's 20 people on the screen, it's also confusing. So maybe just turn on your video when you speak up, please. So in general, the logistics, I think the agenda is pretty obvious. I think the most important thing is if you have a problem with all of this and find out it might not be me, it might be the system, there's an issue link down at the bottom of this slide. Please report to increase the quality of the experience for everyone. I think that's very appreciated, especially if, yeah, it's a recurring problem for you. So as I already said, Alexei, hi. Hi, I'm Hank. And now comes the very important part. We need minute takers. So because we will talk about things, and there's a link here on the slide. There's a link in the agenda. It has a little notebook page and a pen on it. If you click on it, you get redirected to a Cody MD. That's where the minutes are taken. So what we need here right now is a minute taker, at least one, preferably two. And this is a hard blocker on the session. And Michael, thank you. Do we get a second one, like a fallback? Fallbacks don't have as much responsibility. They just have to take care that Michael is doing his volunteer job. Sorry. Yeah, presenting, for example, because I think he will be the first presenter. So we need a second note taker, please. They may be in the room, they may be in the Meet Echo virtual attendee list. That doesn't matter as long as you can click the Cody MD link. Ah, Alexei is mumbling to me that he might be compensating for the lack of attendee volunteerism, but I still want this to give it the next 30 minutes, maybe seconds. Anybody up and awake? Yeah, some people might not be as awake than others. Okay, if you want to follow the discussions, you will click at the note anyway, because typically people follow the notes. If you think something has been written down incorrectly, just correct that. That makes you a support note taker. So Alexia, unfortunately, now has the second note taking duty. Yeah, again, the Meet Echo link apparently found. If you're in this meeting, it's on the bottom of the slide. And then we can go to the content. Next slide, please. So we're going to have a full agenda, but it is not as full as we feared because we have a 2-hour slot. So there will be time for discussion, and that will be of benefit to the whole endeavor. So yeah, I'm not going through all the items here. You can see Michael's first. Kiran, she has presented last time. Piet is new, and I think it will be very interesting to hear about the future-proof. Next slide. So we have a newbie. So this Iotops working group is intended to be a landing site for people coming from the outside of the IETF with a problem with the navigation, with the navigator missing. And now we want to take over some navigator duty here, I think. And then last but not least, Hannes will tell us about the DTS 1.3 profile for IoT. I think that would be very interesting for most of us. And then we want to go into the rest of the time, and we don't have to do this all the time, but hopefully most of it to talk about a working group deliverable. We started that discussion last time, but I think we've came closer to that, and we will actually have some slides on that. So, first in line, first in presentation line is Michael, and so you're now free of minute duty, and the microphone is yours.
Do you want me to project or do you want to control yourself? I'd like you to put my slides up that you used before. Um, but I have to,
The most sophisticated scenario.
so I have to reload. So hold on. Log into the data tracker.
Square.
So this, yeah?
That's the one.
How do I actually pass control? You go to my name and you hover.
Many names. That's nice to see.
Yeah. Hover to the right. No, that's the wrong one because that's probably me logged into Jabber. Look for another one without the space, with the space in the name. Hold on. Alphabetically sorted.
Maybe you are on top because you're
No, it doesn't matter. Just can't do this on top.
okay.
You can just connect to it.
Yeah.
I don't see you. Yeah, you know why? My phone probably has slept again.
Get into the box, Michael. We will do this for you.
All right. That's good. I'll just tell you next slide. Shall I just do? Yeah, I'll just ask you for the next slide. Oh, I need to cancel.
Yeah, we pass it over to your Java account. That doesn't
That's
really help.
well, you can't pass it, but that's the one that's probably showing up. Okay. All right. So I'm here to. This is a follow up for to talk that Nick gave the last IETF. Um, so I'm involved in a UK group called the IoT Security Foundation. It's an interesting group, a little bit in the scale of IETF to complete marketing. It's probably about here. Okay, so not some real technical issues, but not as technical as IETF. And it's created a working group called Many Secured,
And within that, there's an effort called the Secure Usable Internet Browser, or browsing, maybe is the better way. And so we came to you last time with the problem statement. Next slide, please. I'll just mention that I don't think Christian's in the room, but Christian is an IETFer that got dragged into this, and some of these other people are coming from other directions. So, what is the problem? We'd like to be able to browse securely to the devices in your home, be they printers, refrigerators, or thermostats, whatever, things in your home. So HTTPS everywhere. That's the goal, or maybe some other security if someone has it. And the problem is that, well, devices, they don't have names and they don't have certificates. And if they did have certificates, the certificates content don't match the IP address that you probably have to use to reach them. And that's the problem. Um, and so today I'm going to talk a little bit about some of the solutions that we have thought about. One of the interesting things that's kind of unsurprising is that when we talked about this last time, the Jabber room erupted in basically comments of, well, this is an easy problem. Okay, you just need to color it with a brown pencil and there'll be no issues, right? And the answer is, well, that's great, but unfortunately, brown pencils are not available, in this context. Or there was a lot of interesting things. So I actually would encourage you, I had to dig around for the Jabber logs. I would encourage you to go back and read what, you know, 30 intelligent people came up with in 20 seconds to figure out what to do and what some of the issues are behind them. Um, we This group is open to uh, outside participants. You don't need to be a member, but it's a little bit more closed in the IETF, unfortunately. So we do need to invite you, but you'd be very welcome if you want to do that. And I just say, Tuesday was it? Tuesday was 6 man. Um, there's the question as to whether or not you can even put an IPv6 link local address in your browser bar, and the answer is you can't right now. But as soon as you can do that, of course, the next statement is I'd like it to be secure, and so this is a bit above that as well. Next slide, please. So I have a bunch of slides that start with hack because I'm going to say that none of the solutions are particularly perfect. Okay, so the first version is, you know what? Um, there isn't really a problem. The problem is that the warning that the browser puts up is so scary that most people won't click through it. So the question is, um, if we could make that uh, uh, warning look a little less scary, such that people, when it's a linked local address, so an RFC 1918 that's directly connected, or a ULA that's directly connected. So, if you're on 192.168, 1.1, and it's on 172.16, well, that's not directly connected. It's somewhere else on some other network, right? So the one that's physically plugged into your computer. If you go there, the idea is that the browser won't give you quite such a heart attack, okay, and will allow you to essentially accept the certificate for this device, put it somewhere safe. It's essentially a trust on first use, and that's about it. And this is the simplest one, but it's also the simplest conceptually, but it's probably also the most difficult politically to make happen. We basically would have to convince the CA browser forum to create such an exception, and the browser makers to actually um, be willing to deploy this. And of course, there's a lot of UI and other issues there that we'd have to talk about. Next slide, please. So this is in some ways the most brilliant of them all. And uh, Christian Amsus has actually implemented some of this and came up with some of this stuff a little bit independently. And then we discovered that there were 3 or 4 IoT vendors that are actually doing this right now, because you don't actually need any permission. And of course, this is the best part of permissionless innovation, is the lack of permission. Um, so basically, the device leaves the factory with a certificate that has a wildcard in it. So an example here, you have star dot, FO crypto 1D, and it's rooted somewhere in the manufacturer's DNS zone. And there's an HTTP server that you connect to, HTTP, not S at the moment, and it redirects you to this link, right? And when you look up that name, you discover it returns 192.168.0.1, which was the IP address of the device. And you might notice that the hex part in there maps directly to that address. And so, in fact, the DNS server isn't keeping any state or any wonderful stuff. Whatever query it sees, it turns around, removes the hex and says, "Well, it must be at that address," and returns it. It's actually out there. You may know if you run OpenWRT, this isn't going to work. It will in fact filter out any replies that have RFC19 addresses in it. It will not filter out ULAs, so yay IPv6, or maybe the other side of it is, unfortunately, OpenWRT doesn't know how to do security for IPv6. So the attack is otherwise that systems or browser JavaScript will go and scan your network using your browser. But this is out there, and it's kind of a cool hack in many ways, because it's relatively stateless. The vendor does have to be involved and does have to run a service. But other than mapping the IP address, the name to the IP address, which is just DNS, the vendor is not involved at all. There's no call home. It's cacheable, and conceivably, someone could even put up if the vendor died, someone else could put up a service, or you could stuff that number into your local OpenWRT hosts file or something like that if the vendor is truly dead. Next slide, please. Oh, please ask questions. Please interrupt me if there's something is unclear there. So in this version, it looks very similar. The difference is that there's no wildcard. It's just the regular address. And the important part is that when the device boots, it calls home and basically tells the vendor, I seem to be at IP address, 10.1.1.1. Could you put that in my DNS, please? And the vendor does that. And now it's really just bog standard DNS. We can do this with RFC 3007, which is the DNS update protocol. Or you could use a wide variety of proprietary HTTP based ones, which if you have ever done anything called dynamic DNS or whatever, then it's exactly that's exactly the problem. And we don't really need standardization because it's between the device and its cloud component, and it could be whatever. Okay, does require more state, so there has to be a database at the vendor of mapping names of devices to local IP addresses, and if that state that dies or disappears, then the device has to figure out when to renew it, and of course, the vendor has to continue to exist and serve that name. Of course, that can be outsourced. This would be much easier to outsource than the previous system. It's just a zone with updates. It's unclear if anyone's doing this yet for HTTPS, but we know that this happens all the time with otherwise. And people do this, on their own systems. They put up a Raspberry Pi, they do a wget, blah, blah, blah. They get their outer IP address with a port mapped in, and they get a Let's Encrypt certificate. And people do this, certainly, engineers do this tech easily. The point is we're trying to make this doable for light bulbs and refrigerators. Next slide, please. So this is getting a little bit further away from being trivial, okay? In this situation, the device is onboarded using, well, right now people wind up with, an LG app for your LG refrigerator and a Samsung app for your Samsung refrigerator and all this kind of stuff. And the way that it works now is that if there's any security, it's all private. So the idea, though, here is that we will move towards having a kind of app or a skill, which is the word that the intelligent speaker people use to describe an app, that interacts with the app, the device, does the onboarding, and that process collects some kind of a certificate signing request and enrolls the device perhaps into what is probably a private PKI. And this is there's existing practice. Our RFC or my RFC 8995 does essentially this. The chip matter effort is doing essentially the same thing. DPP could do this, and there are other efforts out there that basically are saying, okay, we're going to somehow bring the onboard the device, and we'll give it a certificate and a name, a locally relevant name, while we do that. If you do this in the simplest and stupidest way, your phone is going to onboard the device. Your phone will know the name and the certificate and have the trust anchor of the device, and that'll be it. And so then you go to your desktop and you're like, oh, well, the device is not secure, and I don't even know the name. Well, so that's a problem. So the question and the challenge in this thing essentially is, if I do this and I want to do this, how do I propagate this information throughout the home? And that's an unsolved problem, but it may not be that complicated a problem, right? It's just, some kind of a trust anchor discovery protocol that runs on multicast. Sounds like something to me that would fit into DNS-SD or something like this. And maybe actually would be doable as a browser extension or something like this. And that would basically let you get the local trust anchors and name service for that. Next slide, please. So same thing, but we're not doing it from your phone. Your gateway would do this. And now we're getting to, okay, this really does need to be some kind of a standard. The gateway would be involved. As I said, Chip Matter, Brewski, they do this, and running it in the gateway makes a lot of sense. But since it's the gateway involved, we can also imagine that somehow DHCP is involved, or LLDP, or some other kinds of things that could work for this. Um, but but basically, we're now into a state of where the device, this is really a proper onboarding. The device really has to be involved in this. This is not just a kind of a hack around the edges that gets us something there. So these are the four things that we've detailed a great deal. The links that I've put up there are to our documents there. Um, they're all in Markdown and Docosaurus. If you want to comment on them, that would be wonderful. And that's really it for me from today. Next slide. So I want you to think about, imagine you're in a field and there's a nice cool toy nearby and you have your phone. You should be able to securely reach out to it and control it, right? Without going to the cloud. That would be my ideal, right? Any questions? Any comments from the Jabber room?
Yes, Brandon.
So what I've noticed through all of this is that in each case, whatever the mechanism it is that you use to get the trust anchor into your into your device, that's ambiguous. Sorry, into your browser, is also an attack surface. And I haven't seen anything so far in this. Well, no, that's not true. The two of them were all right. But the two that use conventional PKI wind up broadcasting a whole bunch of information about your network into a vendor-controlled DNS. And the others open a new attack surface for someone to try and break into your network. So I guess I wonder if there's something that we can do that sort of splits the difference and doesn't have both of these problems.
That's an interesting question, Brendan. And you're exactly right. I'm just going to kind of repeat it back to the room and to you. So the first two involve some kind of IP address information being shared with the vendor or the vendor's DNS server. But the trust anchors can come from the normal trust anchors because the vendor either has allocated certificates with the right names already into the public web PKI, or is going to do so less with Acme at runtime. So there's no trust issue, but as you say, you're now sharing stuff with IP addresses, but that's about it with the vendor. And the other mechanisms, of course, now involve, as you say, there's now some new anchors that you need to rely on. And if you rely on new anchors and new namespaces, then what you're saying is that anyone could possibly insert new anchors and new namespaces. Did I get that right, Brendan?
Yeah, absolutely. I mean, there's a local in the naive solution that you presented on slide 3. It's a relatively trivial attack if someone has physical access to your network to get you to connect to things they shouldn't. So I mean that opens the door for malicious implants and things like that. So I really wouldn't support that one. It's quite dangerous.
Okay, Eric?
Yeah, sorry, I can't log in. I don't have my laptop this morning, which is why I'm not there. Eric, not Mark. Um, so the other place this happens, similar things, is in these enterprise onboarding things where they need to give you some certificate to trust, some root CA. Please add it to your keychain type thing, right?
Yes.
And have you looked at those mechanisms as well? Because I don't remember exactly how complicated they are. It's been a while since I've done this, but and it's basically saying I'm trusting whatever you gave me over HTTP or over a QR code to be a trust anchor, right? However, I found
So,
that for my
so,
device.
so so at this point, I would say that the enterprise space is not rich in lots of experience with them, but that effectively, Brewski, for instance, is intended as an enterprise solution, for instance, and there's other mechanisms like that. Um, that and one of the features of them, though, is they're because of they are intended as an enterprise solution. There's an assumption that the enterprise is capable of running a PKI and is capable of communicating those trust anchors securely to their desktops, right? So the typical enterprise, sticks a new trust anchor into Microsoft, whatever it's called, group policy, and then everyone trusts it. And so that side of the trust problem is
But I
solved, right?
but I think there's other things where here's something that your iPhone picks up or your laptop. Have, I don't know if I did this with Linux, but where it basically says here's something that you need to add to your trusted root CAs, right? So that we can do TLS man in the middle.
Yeah. There's
But
absolutely you can download. There's a MIME type, right? And your browser sees that, it will say, it'll put it up and say, do you wish to trust it, right? And that's still there. I think in almost all the browsers, it's still there. But in some cases, it can be turned off,
mhm.
or like enterprises would like to turn that off and they control it, or um, the user is simply decides they're not competent to make the decision, and so they'll always say no. And it's probably good that we're training them to always say no, because we don't want them to gratuitously adding them trust anchors, right?
And you're trusting it for everything as opposed to just
That's
for a
right.
device.
And there's no name path constraints or anything like that usually on it. And that's actually what we need. Torlis.
Tolles Eckert. Um, so the one thing we eliminated in Anima is this really terrible, pre-deployment location thingy,
Yes.
which in a large environment like an enterprise or so is really large cost factor. On the other hand, if I understood, maybe I misunderstood the scope of where this is meant to go to, like in the home or so,
Yes.
you're always physically handling these devices. So I was wondering if bringing that option in there, because it was never, there never was this option in the home that you have a secured location like the trusted Ethernet port where you know what you're plugging into. You have no external network connectivity, but only your enrollment equipment, and then
Faraday
you
cage.
brand that equipment to you. Maybe that bringing that idea, into the home could help as as a solution component here.
I think that's a great suggestion. Go to the bathroom down the hall on the second floor and plug in the device first. And it's not a place where anyone else goes. You don't, or if they do, then they're already in. But I think that's a brilliant thing. The problem is that, of course, we have devices that don't have Ethernets. They
Well,
have
with the
only
Wi-Fi,
Wi-Fi.
you have, as the master of the house, of course, also the key for the one SSID, which has exactly the same property, right? So
Yes, the issue is in most cases is how do you convince the device that it's supposed to do that right now? And very much the Matter effort, I think, is in that direction. And they even have, I don't know, 27 codes to say which combination of buttons you're supposed to push to put the device in that mode, and to doing that. So that's kind of there. But the result of that effort is that the device is enrolled into your private PKI.
true, but I mean, if we start talking about the Wi-Fi devices, as you said, they're all type of crappy, but very often reuse things like device opens up its own access point, so it's discoverable by other devices and so on. So I mean, I think that's a longer discussion.
That's called soft AP
Yeah.
now, and apparently there's patents on it.
Yeah.
People are not happy, but Anyway,
But-
I think I've used too much time already.
Yes.
Yeah, we have the end of the line. And I would like to remind everybody, if you can be physically in the room, before you go to the mic, I know, Eric, you don't have an equipment with you, but press the raise hand button, please. Yeah, next up should be Kiran. Yeah, and she's already in the queue. Welcome.
You
Wonderful. The floor is yours.
wonderful. Floor is yours.
But I hear myself.
But I hear myself.
Yeah, these are not my slides.
Oh, yeah, these are not.
Oh,
Definitely.
yeah, definitely not.
And I can shut up.
And I can shut up.
Sometimes I love this echo.
Sometimes I love this echo. Yoo-hoo.
Okay, so can I control the slides myself or you will drive them for me?
Kieran, would you like
Would you like
or
would you like to tell your mic?
Yeah,
Or-
that'll be better. I just,
You want me to do an echo? Echo.
When we do an echo, echo.
okay, I got it. Good morning, everyone. I'm Kiran. I wrote this document along with my colleague Lee Chun at Huawei. And we are going to talk about how to support and realize virtualization of PLCs in industry network. This is built on document we presented last time, and pretty much everything has changed about that document, and a lot of it was driven by the motivation that problem statement or what we were trying to solve with our framework document wasn't very clear. So what we tried to do was pull out a very specific portion of virtual PLC and build the use case around it. So some pretty obvious and interesting problems came out, and that's what we decided to share in this document. And since the topic is about programmable logical controller, programmable logic controllers, so these PLCs are like rugged computers. They control and monitor devices and also manipulate the output on the factory floors or industry systems. They're pretty much the fundamental building block for automation, whether you want to perform sequence of operations on a smart manufacturing or control motion for a specific robot, or just collect continuous monitoring data. The PLCs are the computers that are controlling the devices. They come in different shapes and sizes. So when you're talking about automation and you want to add large number of devices, you end up putting a lot of physical computers, and since they have to be they have to be in rugged environments. Sometimes they have to be dust proof, humidity and moisture proof, and temperature proof. You have to build some sturdy cages around them, and what that ends up taking a lot of your factory floor. So the problem we were trying to look at is that how do you handle the scale of these PLC devices? The good thing is most of the devices are, these PLC controllers are pretty much, they have the same uh, design, like you have a control unit which comprises of CPU and memory, and then they connect to IO modules, which then directly talk to field devices on the factory floor. And in order to handle this problem of scaling and automation, we thought about the virtualization approach where you can scale out and elastically change the CPU and memory configuration. Because so what's related to automation is number of process controls or the sequence, the depth of the sequence that you want to perform in terms of controlling a particular process. Like you want to control certain machinery in one cell and then correlate it with sequence of operations on a different site cell on the factory floor. So these type of actions require a lot more processing power and more memory. And virtualization of PLCs is one way to achieve it, because then based on what your process is, either you can allocate small amount of memory, small processing power, or you could go even beyond that. And so what we do is we formally define virtual PLC, which is the hardware agnostic abstraction of control unit and memory functions of PLC. What it needs now is an interface to the IO modules, because you have abstracted out CU portion of the PLC. And this is not really an unrealistic concept. All the devices above PLC have already been virtualized. We have already seen use cases where HMI, SCADA, MES, these devices and equipment have been virtualized. They are running on commodity networks. And in fact, PLC is the last component that hasn't been fully virtualized yet. And once we have done that, it is actually a major step towards integration of IT and OT, because then you can take a PLC device as another function in the network and correlate with IT operations or application level functions and put them together on the IT network. There are other benefits of PLC. Some of them are pretty straightforward in terms of what virtualization brings for us, in terms of scaling out and elastically adding or allocating resources for that PLC. So if you have much bigger pipeline or the sequences of operation, operators can allocate a lot more processing power and memory to it. And one of the many times operators are using different PLCs to control lower level PLCs. So now with this approach, we can visualize an NFV platform or a service function chain kind of thing, where you can correlate all these PLCs together, and if they reside on the same platform, you have a very compact data movement. You're just moving your data from one function to the other on the same platform. So that kind of simplifies how operations are working on a factory floor. It also gives a tighter integration with applications. So you can also place high-level applications, business logic sitting next to it. And edge compute becomes a lot more realistic. And it's very interesting that once we have moved all the PLCs, not all or whatever, some few PLCs into the edge compute network support, we can look at edge data centers as a multi-tenant solution, where a operator on a factory floor, they do not need to invest that much on the memory and compute infrastructure, and they can lease the resources from a third-party vendor. Or if you want to interconnect multiple sites together, that edge compute network can integrate applications from different sites. And we also have constraints for low latency applications, and that's where IETF technologies like DetNet or other high precision control algorithms can be used. The benefit will be that most of the sensitive silicon part of PLC, which is your control CPU or the RAM part, you have moved them out of a hostile environment, which is so the amount of the volume of rugged gear from the factory floor has reduced a lot. And how we realize digital twins, that also becomes much simpler, because now your PLC is in a software form, and integrating into some kind of a simulation model becomes much easier. And so how do we realize these virtual PLCs? There are three different approaches. The first one is just abstract the hardware. So you will have a program or the PLC logic that you can run on commodity hardware or any hardware, so that just your CU and IO part are integrated. In that case, your interface with rest of the applications on top of PLC has not changed at all. So this is a good abstraction, but we don't get anything out of it. And the second option could be within a zone, like on a factory floor. we have actually separated out CU and IO parts. In that case, it becomes a problem of how do we provide a common interface from the CU portion to the IO modules on the factory network. And the highest degree of disaggregated case will be when we are actually crossing the zone boundaries where applications and virtual PLCs are residing together. And we need to support a common interface over a WAN or a large scale network, and you're crossing the factory zone boundaries. And the third case will be the ideal approach that we want to achieve. But for that to happen, we will have to pretty much break the hierarchical model, the Purdue model here, since we are moving the devices from L1 and L2 level all the way up into the enterprise applications. So that imbalances the security paradigm of Purdue model. And we need to find a way to, so basically when we go from physical PLCs to virtual PLCs, pretty much we are looking for a disaggregated model. And that is something we need to look into in order to support virtual PLCs. So based on this input, we came up with some problems of realizing virtual PLCs. And first one will be related to now your control unit and IO modules are separated. So what will be the how these PLCs will speak to IO modules? Since they're in the software format now, any PLC can control the IO modules or the devices underneath. How do we provide authentication and association mechanisms to these devices? And then there is also a problem. How do we determine if a virtual PLC was talking from somewhere outside your factory zone network or it was in the edge cloud? In that case, your security policies have to be programmed accordingly. Then there are corresponding expectations from the network. So if you see, when we move virtual PLCs away from the factory floor, then there is nothing but just the network between PLC and the floor devices. So most of the intelligence comes into the network, how the network is interfacing with those devices, and the intelligence about the compute and memory, how the data is stored, has moved out of the factory floor. And this means that we have an opportunity to define more meaningful policies that does not require deep packet inspection, but we can come up with a new model in which we look at actually what is my end device and how I want to connect with it and what kind of processes are allowed to perform on it. And then there is a limitation of hierarchical structure. We need to transition from hierarchical to disaggregation. How do we go about it? And then there is this underlying thing that devices still speak different kind of protocols, and how will we support those protocols like Profibus, Modbus? The interface to IO modules does not change, and how our common network interface will support these protocols. So based on that, we can look at some requirements such as what are the addresses for these virtual PLCs, depending upon how they reside in the network, and what is the scope of authentication? How do you authenticate these virtual PLCs? Because we still want to preserve the safety and security of how operations are performed. And we also need to define some key performance indicators in terms of how we describe the latency, resiliency of the system. If my PLC is in the edge or cloud, how do I make sure that any process request that I sent from there was accepted and was properly processed by the IO devices? So we can leverage some of the existing technologies, DetNet, TSN, and come up with more resilient solutions on top of them. Then there are obviously corresponding network environments, and this is where I think it leads back to our framework draft, that now we have an opportunity to build a converged network because we have already taken care of most of the intelligent components out of the network, and our interface can now be really unified because IT and OT devices are pretty much sitting together. And the interface, how CU to IO module will happen, is something that will be one of the problems we need to solve. So that's pretty much it. Before going deeper into it, I just wanted to share that how these virtual PLC realization work will be considered within IoT ops, or how do we proceed further with these things. The things I'm trying to answer, at least raise questions from problem statement, are like, how do we disaggregate different security zones? How do we come up with a formal method of connecting to edge compute networks? How do we define our virtual PLCs? And hopefully, if that work is consumed and we translate into the framework, which is based on unified fabric, and share it with external STOs that are really working on industrial networks, and tell them, hey, this is the informational or best practices work that is coming from IETF. We have some protocols and technologies that could help you deploy your systems, and or how you use IETF to solve these problems. Yeah, so that's pretty much it. Thank you. Any questions?
So this is Hank, not a chair.
This is Hank, not a chairs head.
And could you mute yourself while
And could you mute
trying
yourself?
to speak? I can do it. That would be nice. So thank you. And then, so yeah, this is after hearing the problem statement, the requirements, this is a lot of things that on a lot of different layers. So when I look at this problem from my personal point of problem awareness, already the different field buses, like you said, Modbus and Profibus, and then we have the SCADA, the S5, the S7, already getting that aligned and then a little bit homogenized. That's its own problem, right? So yeah, that's somehow involved in all what you do, but that's its own problem space. And then you have the virtualization of the glue, which is now the virtual PLC that would handle that. And IETF technology can help you do that. But I think passing on the messages in a way that is not utterly confusing or from the 80s is, I think, one of the things that would really help this domain, because you're dealing with legacy that will not go away. But in the future, you want to have a better way to set things, do recipes, do the planning, whatever the SCADA can do. It's basically setting and getting things. And I think the IETF has very good building blocks for that. And there are even experimental ones, like new ones, like the semantic data format, right? Where the self-descriptiveness of these PLCs is what we're kicking in. So I think this is a multi-problem thing now. And the virtualization of PLCs, I think, is a very high-level goal. And maybe it's very useful to the purpose to segment, like, for example, the messaging problem out. Like I have all these proprietary messages, but they're actually not so many. They're just proprietary. Sorry, they're just old, not so necessarily proprietary. And now we can transform them, I don't know, into JSON or CIB or something, and then go from there, expose them via a virtualized thing that is now very manageable, because it doesn't have to take into account all the different things. You already know how to transform them. So just from my point of view, and I know we don't have a lot of time left, so but that would be my comment with the no hats on.
Okay, yeah, I can take that feedback and try to narrow down it even further, and which actually will mean that not do anything with this draft and go back to the initial problem that we have discussed a couple of IETFs ago, where we were talking about unifying different messages.
we should really close the queue.
Let him-
Hannes, if you really want to, Karl Heinz was first, though.
Okay.
Karl-Heinz, can you
Yeah,
unmute
sorry,
yourself?
I needed to get aligned with Medeco. Sorry, just for me, but one question I have is, as far as I thought about these stuff again and again, it always comes down to the problem that we have real-time systems very often, and we need to have these, real-time network communication, which is going through active layer 3 devices at the end, which usually works not so well. So that's why the deterministic network stuff is there. So my question is, how far along is the deterministic networking technology already? Is that feasible right now?
As far as I know,
Stop my
DetNet is very actively
Stop my
working.
question.
Should I? What happened?
Sorry.
Sorry.
Echo.
Echo.
Kiran,
Should
just
I?
carry on.
Is it
Kiran, just
okay?
carry on.
Yeah, so DetNet is pretty much feasible. I think they have some protocols that are already being developed. And that's one of the ideas, that how do we come up with an architecture that integrates DetNet more easily? And that's where the idea of unified fabric came in. So they have already developed some technologies. They are actually using TSN, I guess, right now. They are building solutions on top of TSN. And I need to plug in with them to see how feasible it is for them. But I think it should be possible to connect from edge compute to at least some factory side using DetNet technologies.
Thank you.
Okay, Hannes.
Thank you. Okay, Hannes.
Hi, this is Hannes. I think it would be good to drag along some people who work in this space and are manufacturers like Siemens. And from our interactions, I know that they are not using off-the-shelf hardware because you pretty much, because of the previously mentioned real-time requirements, you cannot. We at ARM, we have our own class of processors specifically for that purpose. It's called the R-class processor, which uses virtualization, but only because of memory isolation, sort of software isolation, which includes memory isolation, because you can't use virtual memory, because that introduces a lot of unpredictability in the whole scheduling and in the whole sort of response time. So it's an extremely complex space. And if you see what vendors do, they basically rewrite the whole software stack from bottom to top, because current software, like off-the-shelf software that we are typically using in other areas, is not bound to the real-time behavior that you would need in those systems. So it's very demanding. So drag some of those guys along. It would be interesting to hear what they have to say.
Hear what they say.
Yeah, so that's an interesting point. I do understand it is somewhat difficult. And I'm not promoting that we should use off-the-shelf hardware. Even with vendor-specific platforms, you could have benefits from virtualizing PLCs. And as I said, that how you put different PLCs together on the same platform, you can get better integration between applications and software. But yeah, it is a paradigm shift. I do agree.
Well, I think, Kiran, can you stop sharing
Well, I
slides?
think
Welcome to the box.
Thank you.
Once upon you got a star if you stay in the box, but this box is actually smaller now. So. Don't worry about Johan, the cameras are fine. What? Sorry, there will be a slow delay because the data tracker did not recognize our upload apparently. I could do the Jeopardy music, but I'm not doing that. Nah, no, no.
I guess it's my punishment for sending the slides today.
Yeah, it makes sense to send them in time. I think I could literally ban you, but you're taking the notes, so one free. Yeah, that is. Yeah, if you do a full screen with the 11L, F11, and then do the full screen, it should. Almost. Close
That will
enough.
work.
We're going with that.
Right. So, good morning. I'm Pete from ETH Zurich. New here. And today I will be presenting a paper that we originally presented at Kritis in Lausanne last year. But I think it could also be useful feedback here or useful input here. So this is work that some colleagues at ETH did together with Franco Monti from MSF Partner. They're a company, they do consulting for critical infrastructure security. So they do power plants and those kind of things. So the presentation has two parts roughly. First, it's a discussion of how industrial networks are structured today and then challenges that we're seeing in these networks. And then the second part is a maybe somewhat futuristic proposal of how we could restructure these networks in a more modern way. So slide, please. Right. So when we look at industrial networks today, what we almost always see is that there's this very strong hierarchy. And this hierarchy has two reasons. Firstly, the network is hierarchical because the control systems that the network is controlling or that the network is connecting to is hierarchical. And these control systems are typically located together with the processes that are being controlled. So hence the network kind of naturally inherits this hierarchical structure. And then second, there's this general notion that having this hierarchy in your network is good for security because typically there will be security enforcement points between every level of the hierarchy. So the lower you go down the hierarchy, the higher your security level gets. And at the bottom, that's where the most security critical devices would be placed. Slide. Now, we're seeing that this traditional way of organizing the network is more and more being challenged in the last couple of years. So first one of these challenges is that we're seeing changes to the network. For example, in the data center, SDN has pretty much or is pretty much taking over these days. And with the IT-OT convergence, that means that it's also only a matter of time before we also start to see these things coming to the factory floor. At the same time, the IEEE is working on TSN, which will probably make Ethernet a more or less universal replacement for all of today's wired field buses. So over time, we will likely also see all of these field buses being replaced by Ethernet. And these things, they really, from a technological standpoint, they bring the top and the bottom of this traditional hierarchy closer together, which means that almost by definition, it becomes harder to keep them separated. On the other hand, all of these new technologies are typically centrally managed, which means that the relevance of distributed security enforcement and the effectiveness of such methods is being reduced. Slide. Then we're also seeing changes to the automation infrastructure itself. So we've seen already a couple of times that as the requirements that are placed on technology kind of start superseding the capabilities, we're moving to to more general purpose components. Again, in the data center, we've had virtualization. In the industrial world, we're seeing IT-OT convergence right now. And as Kiran was discussing, we're also seeing these virtual or virtualized automation functions like soft PLC, soft SCADA, soft HMI. And these things, or what's interesting about these is that this virtualization breaks the assumption that your controllers need to be placed close to the processes they control. So they could be placed in the edge or in the cloud. And this means that you need a network architecture that allows you to decouple the logical and physical location of your assets. Slide. Then we're also seeing changes to information flows, where it used to be that that flows would really always only cross one layer of this hierarchy at a time. Now there are more and more flows that cross many or even all of the layers. For example, if you have a device that's sitting in the field that's uploading data to a cloud service for something like predictive maintenance, then now you need to punch holes all the way down your hierarchy. And this not only leads to high management overheads, but it's also bad for security. Then we're also seeing changes to the threat models, where with the original network design, the assumption was that the attacker would come from the top and would have to work its way down. With more complex devices in the network that need updates, or with more mobile devices, with more devices that can be remotely managed or increased wireless technologies, it's becoming more and more likely that the attacker can actually appear somewhere in the middle or even at the bottom of the network instead of at the top. And this undermines this assumption of incremental security. And then we're seeing changes to operational models, where now more and more plants are sometimes don't even have anyone in them and they're completely managed remotely. So all this control traffic needs to travel over the interdomain. Slides. So with all of these changes and challenges in mind, what we try to do is come up with a clean slate and think like in the ideal world from a management perspective, how would we want a network architecture to look to support this? And what we've came up with is Tableau. And here on the slide, you see the network that I had a couple of slides earlier redrawn in the Tableau architecture. So one of the first things that we did is we separated end host and transit functionality of the network, and then gave every end host zone a so-called transition point that connects it to the transit network. This effectively flattens the network hierarchy and provides this big central transit network in the middle that in principle has full connectivity between all of the network zones, but then there's a central controller that puts limitations on which transitions or between which zones and in which patterns traffic can flow. And because this transit network is relatively open, all the traffic between the transition points is tunneled, so encrypted and authenticated. Slide. So what's interesting about an architecture like this is that it gives you really a lot of flexibility in how you want to structure your network. For example, you can do things like hybrid plant cloud networks where, let's say you have a physical network that has a number of zones. But for each of these zones, you also use some sort of cloud service, for example, to support the devices that are in that zone. You can replicate certain zones or all of the zones that you have in your physical plant into the cloud. And then by configuring this policy, you can place zones that are physically distant, adjacently close, or logically close. But you can also put zones that are physically close, logically distant. Slide. It also helps with things like multi-homing because you only need to take care of the connectivity between your transition points, and then the logical connectivity of whatever is in your zone follows. Slide. And you can do things like partial deployments in two ways. Either you can just convert one part of your network to a Tableau architecture while keeping a hierarchical architecture otherwise. And this within that part that is Tableau oriented keeps all of your or of the nice Tableau properties. Or you can, if you have a network that follows a Tableau structure, you can also overlay more traditional hierarchical zone transition policy. So logically, it still looks like a traditional network, and then you have more time to transition your policies over time. slide. Can you? No problem. As a technical facilitator for this, we use Mondrian, which is work from colleagues of mine, which creates these notions of transition points in the zone controller in the enterprise setting and binds these transition points together across the interdomain into an interdomain transition zone that then allows traffic to flow unrestricted. My colleagues showed that you can actually do this more efficient than I would have expected, and they show that they can do this with less than 5 microseconds of delay per transit point that is encountered by a packet. Slide. If you want to read more about Mondrian, there's a paper. I will not go into more details today, but instead I would like to say something about defense in depth. Slides. Because what's often argued is in these hierarchically structured networks is that this hierarchy is necessary for defense in depth and to have a strong defense of your network. And specifically the fact that you have these layered firewalls and that you have a lot of heterogeneity in what kind of devices are used in the network is used as an argument for security, and it's said that that facilitates defense in depth. Our take on this is that actually this is not as black and white, and doing these things or having layered firewalls and having heterogeneity does not automatically lead to defense in depth, because that really needs you or requires you to have this security-oriented mindset throughout your organization, and that is something that you can do with and without this traditional structure. And there's also past work that shows that having these really complex policies or complex networks with hard to administer policies can actually harm security in some ways. And additionally, as I discussed in the beginning, the threat models are actually changing, which means that because this hierarchical network model, the security assumptions of it rely or make some assumptions about the underlying network. If the underlying network is changing and if those models are changing, then also your security models or your security properties will stop to hold. In Tableau, we try to replace this by having policy simplification and giving you better control over your policies with more fine-grained zoning, and also facilitating automated network verification by having only one place where your policy is specified. Then slide. We do, however, so we've been thinking about how could we still introduce heterogeneity into the network though, because it does provide a benefit. And in some situations, for example, in power plants or in hydro dams or things like this, you might still require this heterogeneity. And we looked at how can you introduce heterogeneity without compromising the core features that something like Tableau would provide. So flexible network routing and simplified policy management. And our take on this is that you standardize the interface between the various Tableau components. And then you can have a heterogeneous set of transition points that is deployed to your network that listens to multiple heterogeneous controller implementations and, for example, does some majority voting. That all operate on the same policy file, but then this policy file can be verified in multiple independent ways. For example, through manual verification or through different types of automated or formal verification. Slide. So just to recap that, so we've seen that specifically, or that changes to the industrial network, and specifically these changes come from the IoT that's coming up and from IT-OT convergence, are challenging the traditional ways that we defend its networks. We see that some of the assumptions that really come from these that this Purdue-based network is based on no longer hold. So we have eroding security properties, and then we have a proposal that flattens this network hierarchy, enabling more flexible interdomain traffic management, and that has centralized policy management. And then we've shown we've thought about how modern security practices with structured heterogeneity can actually replace this layered approach. And with that, I'm open to discussion or questions or comments. Outrage.
So there are three people in the line that is virtual and not virtual. Wonderful. So Elliot is first. Please, Elliot, go ahead.
Good morning and good afternoon, and a very early morning to some colleagues and friends. Yeah, thanks very much for your presentation. As a side comment, I'm based in the Zurich area. I would love to get together with you and talk about this at ETH or at Cisco where I work, or virtually, whatever people feel comfortable with. Two comments. First, the there's I think a little bit hidden in your presentation, which is I think natural when you're trying to give a summary. The term heterogeneity has to be very carefully understood in this context. There's all sorts of heterogeneity, and I don't think you quite defined it, and it is sort of key to your presentation. So maybe you can take a few minutes after I finish the second comment just to say what you mean by heterogeneity. Boy, I can't even speak today. I had a head cold earlier. Now I'm just tripping over my tongue. The second point I was going to make is that my experience when it comes to these models, and if you look at the way that ISA 99 came together, it really sort of fit itself around what the manufacturers were doing. And now what you're saying is, well, the manufacturers are going to be doing something different, taking advantage of the various virtualization capabilities, the merging. I think your problem statement is spot on. Okay, but the magic here is in the policy, not in the deployment of not in the enforcement, but in the policy. We have gazillions of means to flatten networks in terms of access control, for instance. They exist throughout, since day one practically. So maybe you could talk just a little bit more about this policy aspect in terms of voting and different controllers and how you do policy merge. And I realize that's a very lengthy subject, but maybe a minute or two on each of these would be great. Thank you.
Right. So the first comment, the question was, what is heterogeneity? So here, what I'm trying to capture that is the idea that if you have a network where you have different security enforcement mechanisms or even different just firewalls that are designed by different vendors that are completely independent products, there's this notion in this industry that if you by having that, an attacker would need to. So let's say that from the top layer to the bottom layer, you have firewalls from 5 different vendors in there. There's this notion that, okay, that's good because the adversary would have to find holes in 5 different firewalls or 5 different firewall implementations before he can actually break the network sufficiently to really hit your lower field layer there and to really be able to affect the physical process. Then for the second comment, I'm not 100% sure that I fully understood what you're trying to say there.
If I may,
Yes.
what I'm saying is that how is it that you program? How do you program access, and how do you decide what needs access to what, or what's an access violation when you're not enforcing but merely observing? Thank you.
Right. So in this setting, we would be enforcing, right? Because you're only this solution, which again is from our perspective, this is not a final solution. This is kind of a first conversation starter. Is the access management is done on the level of the zones, right? So which transition to which zone is allowed and which one is not. And this at the moment in the Mondrian implementation that we have is very enterprise oriented. So it's based on IP ranges. We actually, I find this a very interesting thing, and we would like to look more into how can we change that to be more practical for the industrial setting. But we actually also find this quite challenging because it's very hard to get corporations or get access to real world data from these kind of plants. So
They're embarrassed.
So yeah, it's actually one of the big problems that we have in the space, and finding the best way to really tackle or to be able to tackle these problems.
So again, Turles is next, but Michael, you have 30 seconds. Yeah, make it fast.
Well, thanks a lot, but please take it positively, right? I mean, it was great marketing, but I didn't see a single second that was explaining to me what Tableau was doing. So I'm really just guessing like it could be a set of coordinated working distributed firewalls you're throwing in that are somehow magically creating the zones. So I would have really loved to spend 1 minute out of the 15 minutes we've been doing all of this on some technical explanation what it really does.
Yeah, I think that's a fair point.
And we have the list, so you can add some explanations to the list. It's visible to everybody here, and as even Michael might have more comments, please put them if they're addressable also to the list. Thank you. So next up is I think Karl Heinz, from the top of my head. I hope I'm not doing this wrong. No, I'm doing this wrong. Who's that? Oh, Marcus, sorry, both of you. Yeah, that was a little bit confused to me. Hi. So, floor is yours. Presentation should be on the way. Yeah, that's one. 3, 2, 1.
Would you like to control them? Or?
Who can control the slides? Can I control it?
We just say next slide. We will do the.
Okay.
Thank you.
Yeah, hi, I'm Marcus, and in this talk we would like to present our envisioned communication architecture for future energy grid operation systems, which has to be low latency, reliable, and secure, which is part of our research project Venus we are currently working on. And the scope of this talk will be, next slide please. The scope of this talk will be, as I said, introduction into our research project Venus as a whole, and then we will give technical details about the communication architecture we are envisioning here. And the goal with this talk is to find out which IETF solutions might be considerable for contribution by the project, and also which IETF working groups might be interesting for the technologies we are facing here in Venus. And yeah, as Henk already said, we are two here. I'm here with Karl-Heinz Genzel from Aperias, who has mainly driven this talk here at IETF, and I'm Markus from the Chair of Communication and Distributed Systems at RWTH Aachen. Next slide, please. So this is our agenda, but I would suggest to get right into it. So next slide, please. So the energy distribution grid is changing, which is mainly driven by measures to meet climate goals. So we are basically moving away from fossil energy sources, going to generating energy from renewables. And this also means that the production of energy moves from conventional centralized power plants to distributed power generation, for example, by solar cells, basically placed all over the country. And this also introduces changes to the, as I said, distribution grid, but more specifically to the power flows. As now not only a few centralized power plants are generating the energy, and the distribution grid has to distribute it to all consumers, but all of the power can be fed into the, or need to be fed into the distribution grid all over the place. And yeah, this basically leads to multi-directional power flows. The problem, or one problem the distribution grid providers are facing here, is that their traditional static distribution grid protection systems cannot cope with that. So they are basically parameterized once or 2 times a year manually at every station out in the field. But for such multi-directional and highly volatile power flows, it needs to be more, they cannot cope with these volatile power flows. And yeah, this basically means that they, for example, can detect changes in the power flows and misidentify them as a short circuit, which then basically can result in false curtailment or partial shutdown, which of course is not great for the consumers, but also it is not great for the efficiency of the power grid and power generation as a whole. Next slide, please. And this is where Venus comes into play. And Venus, we want to basically prepare the protection technology to cope with these new challenges, with these highly volatile multidirectional power flows. And the idea here is to introduce an adaptive and interconnected grid protection system. And we can see here on the right a scheme which basically depicts the envisioned architecture. We can see here the grid control center on the top, which basically has information about all flows going on in the power grid, and then is able to calculate specific protection parameters for the current scenario the power grid is in. And then these protection parameters need to be transmitted to these protection stations or protection hardware in the field. But this has to be done over a low latency communication infrastructure, as these control messages need to arrive at each of these stations at the same time, because we do not want to have any inconsistent states in our protection system. So each of these devices need to be configured at the same time. And this is also the reason why this communication infrastructure has to be reliable. Because we do not want to lose any control messages. And furthermore, this system also needs to be secure, as we do not want attackers to be able to intercept any ongoing communication. For example, to attack the power grid and, for example, shut it down. But also the systems in the field need to be secured hardware-wise, to ensure that attackers or attacks are detected here. And how we would like to face that in Venus is what Karl-Heinz will elaborate now. Next slide, please.
Just a second. So I see Torles has raised his hand. Yeah, no, but I think maybe questions are in order right now, or do you want to disrupt your presentation flow?
We can take the question now.
Yeah, just protection can happen at so many different levels, right? So I was just wondering if you're talking about packet level or something higher level as well as the first point.
So the protection is at the energy level. So it's basically completely this is what the electrical engineering guys are doing in our project. So we are not alone here. So this is completely in the power level. The protection here is meant.
All right, thanks.
Okay.
So when we talk about protection, it's about safety. It's not about IT security at that point. It's about how the energy grid is shut off in cases where it's needed before stuff breaks. So then about the actual communication, the IT part of this, because the first part was more about energy. That's the stuff I wanted to talk about now. Just to make it more obvious, for a protection system, right now, if you configure it once, you put it into the grid somewhere, and it will stay there and will work there until it's decommissioned. So it will not have an actual connection to some kind of control system which actually changes parameters. So it is the only thing it does some reporting to the grid control center, and that's why we have these new communication flow where a protection system is now not anymore just a reporting system which is statically configured once, but now it's a system which is configured all the time and has different profiles and will react on different states of the energy grid. So it needs to communicate also from the configuration point as well, and not just from the reporting point of view. And for this, we have some kind of parallels to the PLC talk we had before. We need to have a communication which works also sometimes in real time. And that's why we have these three requirements: low latency, reliability, and security. And in the low latency part, we started to tackle these requirements. We looked into IETF standards and other stuff, and we said, okay, for low latency, we might be able to use SDN to actually reserve paths to systems and to react on failures and do some failover for. Also, we can try to use for reliability and a little bit for low latency multipass technologies like multipass TCP or multipass QUIC, or to be able to transfer more data on different paths to the system and be faster, be quicker at the end, be more reliable, so that if one path fails. And at the last part we thought about was how can we make these systems which didn't need to be secure at the start now need to be secure, since they are actually communicating through the internet and are reachable through the internet. And then we looked into trust execution environments to actually protect some of the code which are in these systems, which is like the code that is very mandatory to ensure the safety or the safety functions, and also look into how we could actually use the TE and had the TEEP and found TEEP and SUIT on the IETF agenda, so to speak, and also for security found RADs, and that's the stuff we wanted to apply for security. But and that's the next slide, please. But we are still at the beginning right now. We also discussed if we really want to present this today, but we thought after talking also to the chairs, it would be good to actually start with our IETF contribution from the beginning of the project. So ask you guys and on your opinion, on your experience, and all the work groups you know, what could be considered or should be considered from our side. Where should we also look at? Maybe besides the technology you already said, maybe one of these technologies may also be not the right fit. And that's why we started here with the aim to contribute to the IETF and also ask you all which work groups would be interested in results or would have questions we should actually tackle in our project.
So Charles is the next at the mic. Yeah, I'm Charles Eckert again. So I'm still kind of please reach out to me. We can certainly chat offline, for example, on Gather or so after the meeting. I'm still quite unsure about the exact scope of the project, because I would assume that a lot of the things you're looking for as far as network reliability and signaling and everything is concerned should be solved by the latest generation of the work going on the synchrophaser grids of the different continents. But maybe you're looking into a more edge use cases where you're not really having to deal with the synchronization of the phase of the power generation, which puts very hard time and reliability requirements on the network. So, and you're looking for a more lightweight, different scoped solution for probably soft switch over, right, with interruption in the middle or so. So that's why the better understand the use case, I think the more easy it would be to give more recommendations. What you had seemed to be top down. So I think you haven't arrived at the network level, but we're having things like DetNet and then appropriate routing technologies for that. Obviously, IEEE, TSN is there as well. So yeah, there are multiple levels where you can look at things.
Thank you.
Michael Richardson at the mic. Thank you for coming to us with this. This is really actually quite exciting. The IETF is always looking for operators to help and participate in figuring out where things go. And in this sense, you guys very much are operator or proxy for operators, and you have lots of nice logos on the bottom, which is something we don't always do. But anyway, the thing here is though that all of those things that you said are really good, but actually what would help us the most and probably help you is to contribute to those working groups the use cases that you need to fulfill. So even though whatever the RATS architecture is, for instance, pretty much done, that's okay if you come along and say, and this is our use case, and it doesn't, how does it fit into this? And maybe it does, and maybe it doesn't. And it's okay that if we missed your specific case, it doesn't mean it's illegal or something. It simply means that no one contributed it yet. So I think that would be really good, and I would be really excited to have you in all of those different groups. And yes, as Charles says, DetNet and all sorts of stuff. And it sounds to me like you have a multitude of different things, and there's a little bit of what's the right word? Well, we can just build it with everything, right? Kind of thing that I'm concerned, but so you'll have to figure that out. What is enough? Do you need Quick and MPTCP? Probably not. Maybe SDN is actually a failure because you have a single point of failure and you really want to run OSPF in the end, actually, and that's good enough. I don't know. I have experience with VoIP networks where people try to do STP for VoIP failover and it doesn't work because it's multiple seconds. You need to run OSPF to get and have equal cost multipath for VoIP. You can't do that way. That's kind of things that you will hear, and if you come to the IETF and talk about your requirements in the different areas there. So I think you guys have a very a busy schedule ahead of you, where you'll have to go to 5 or 6 different areas and 3 or 4 groups within that area. So it should be very exciting for you. May you live in interesting times.
Yeah. So we have like 2 minutes left for 2 minus minutes left for 2 people. So yeah, go ahead.
This is Dave Robin. I'm curious to know. I agree with your work statement. Done a lot of work with smart grid, so I appreciate the real time aspect of some of it. The interesting thing I wrote down from their presentation is this concept of simultaneous action, and that is a problem that is maybe solved in a different way. And I'm not sure whether you DetNet or other methods of reliable multipath, everything you can think of to get messages. But at the moment that you require some action to take place in 2 places, the network could drop. And so if that is really your problem, then you have to solve that in a different way. We've done that with pre-negotiated time synchronized actions. In other words, we negotiate 1 second from now, this will happen, all sides acknowledge. Then at that moment it happens, but the network could drop at the moment. You're not actually basing the action on a message at that point. So if that's your problem, I'm not sure the IETF can help you. That's an application level design philosophy. So the real question what I was coming up to is, where is the ask of IETF here? As we said, we got all these tools you can use, and so use them. I guess what I'm saying is, in this presentation, I didn't see hey, IETF, you don't have something to address this. And the one thing I wrote down for this was the simultaneous action at multiple locations, and I'm afraid that has to be solved in a different way than a protocol. So.
Thank you.
And then Carsten, really quick.
Yeah, so Dave had the right question, and I think I would really like to encourage you to actually look at your use case, as Michael said, try to identify the sub-problems there, talk to us about applying the right technology for that. And then your contribution really could be finding out whether the IETF components that we have developed actually are solving your problem or not. Now that is part of feedback to a working group who has just been doing that work, but it's also research. And I would like to point out that there is actually a research group, the Think2Think research group, that is very interested in research in this space. And as Dave mentioned, there are some application layer issues that also are interesting and may have to figure in here. So maybe we should look at this in the Think2Think research group in some future meeting.
Thank you, Carsten. And in the interest of time, Hannes.
You allocated 15 minutes. Can you do it in 10? You only have 4 slides.
Now I can. That was easy. Go ahead. Okay. So this is a little bit different to what you have seen just in the last few sort of minutes, in the sense that I'm presenting to you a work that is done elsewhere in the U2A group on TLS and DTLS profiles. Next slide. And I would like to create a little bit of awareness, and hopefully some of you are actually using or deploying IoT devices and are securing those with TLS and DTLS, and I would like to get your feedback. As a reminder, so there's a longer history to this. Namely, we started off with the work in the Utah group on RC 7925, which was about profiles of TLS and DTLS 1.2 for securing IoT communication. And if you looked at that RFC, it provides a lot of guidance on how to use algorithms and extensions in the IoT context, because for TLS, there is obviously a lot of choice in terms of extensions. Not all of the extensions can be arbitrarily combined to make sense, or even are then consequently secure. And some of them obviously date back to earlier days, so they are not a good choice to begin with. And that's what the document explains. We also made some sort of profiling of TLS in this document. That's why IoT profiles. For example, when it comes to the timeout values, the TLS specification provides some guidance for use in the generic internet, on the web in particular, and leaves it open to other application domains to change those values. And that's what that document did. And also, as a sort of smaller thing, it also describes on how to use DTLS over SMS in the appendix. Okay, so that was 1.2, and it's finalized, and everything great, and people are using it, and there are a number of implementations, production quality implementations, and the big IoT cloud guys use that stuff. Next slide. So fantastic. And then TLS 1.3 came along, and the work on this profile started. Luckily, of course, there's all the algorithm recommendations for the 1.3 obviously current. So this led to a much shorter document, but there's still a few things that can be said about 1.3, specifically now as sort of the embedded implementation. I've also picked up 1.3. Wolf SSL and MPTLS have a 1.3 implementation. So there are people who use 1.3 in their IoT deployments. So that's also a good development. Many of the recommendations can be carried over from the other RC that I just mentioned, but of course there are some nuances and some differences with 1.3 compared to 1.2, of course. For example, in the post handshake, the resumption cases, we added in the meanwhile the connection ID. There's the possibility to use the encrypted client hello if someone cares a lot about the privacy protection and the like. There's also an application profile for use of the co-op protocol with the zero RTT exchange, because that doesn't provide replay protection in the TLS handshake. So you have to, or the TLS specifications calls out that you have to provide a story there. There is a story in a separate document for HTTP, and this is the document that does the same for co-op. And one thing that is still a sort of a controversial aspect is the choice of, or the recommendations for algorithms specifically related to the use of AES with the mode of operation, and CCM8, which has a shorter authentication tag, where this document currently recommends to use GCM and CCM with the long authentication tag instead of the shorter one. So that's a little bit controversial, because that was the preferred algorithm in sort of the IoT circles in the IETF previously. So we are gradually moving away from that, but this is not cast in stone yet. So obviously, if you
work in that space and deploy that algorithm, we would obviously like to hear from you. The DTLS, the upcoming or DTLS RFC also discourages CCM8 for security reasons. So, okay, next slide. So there's a lot of stuff in there. And so the big ask to you is, like, are you using TLS 1.3 already in your deployments, in your IoT deployments? And if so, let us know whether you stumbled across a few things or whether you find some of the recommendations in there useful, or also if you don't find them useful, then obviously we want to hear as well from you. So this is more sort of geared towards the ones who are actually doing it rather than sort of thinking about it.
Right. So please bring your comments to UTA working group.
Yes, exactly.
Which
Yeah,
you
the
can see in
UTA
the-
working group is the right place to discuss those.
And Turles, yeah?
Yeah,
Go ahead.
Klaus Eckert. So I haven't read that, so that looks quite interesting. In the Anima working group, when we were trying to go through security review, I was fighting long and hard not to have TLS 1.3, which was fresh out of the door by the time we did the RFC being mandated, but just 1.2, just in fear of not knowing what speed of availability of TLS 1.3 I would have in the arbitrary low-end equipment, primarily IoT. So it would really be good to hear some more insight from you folks that understand that IoT equipment, right? At which point in time, for any type of solution environments like Anima, Brewski, Bootstrap, all these things, we can actually start mandating TLS 1.3 or even specific profiles of that, where I'll have to wrap my head around the reasons for the specific profiles first. But yeah, so because firmware upgrades in these type of equipment have traditionally been worse than continental shift or so. So that's very interesting work to learn more about this.
Yeah, yeah, as I mentioned, like obviously the 1.2 sort of stacks are very common. But if you switch over to 1.3 on the server side and on the web, it's obviously widely deployed. There are lots of stacks available, so you're really good there. But when in the embedded space, everything takes a little bit longer development-wise. But luckily, you can get commercial stacks in the meanwhile, and yeah, so they are like high quality implementations, very performant, integrated with hardware and so on. So it's good. It's a good landscape today. Yeah, I think
maybe I can have a final comment. So if the deprecation of CCM8 is a topic to you that has been raised by Thomas recently, just on the core working group list again. So if you have an opinion about that, now is the time.
Okay, so we use up a little bit more time than we expected, but I think that's okay. We had a bit of spare. Chairs are starting to think about, after a year of running Iotops, of documents to adopt. Obviously, we'll have a discussion in the working group. We just had some preliminary discussions about possible documents like architecture. So we asked Brendan to do a little presentation to talk about one potential document.
So I originally presented this document, I guess, 2 IETFs ago, and then I let it expire. Next slide, please. And the reason for this is kind of rolled up into what security documents actually are. So I have come to the conclusion that security documents always trend towards one of three things. They either become an architecture, a threat model, or a document that details requirements or mitigations. Next slide, please. So when I wrote this, it was definitely not an architecture. It was not a threat model, though there was a threat model that I had in mind. Mostly what it came down to was requirements and mitigations. But it didn't have an architecture or a threat model, so it was really hard to justify each of those mitigations. Next slide, please. So I had to ask the question, sort of, where does this document go next? And this is why I let it expire. It really needs an architecture or a threat model, but it didn't make sense to just constrain that to only the problems that were addressed in the IoT Nets draft. It was really, that would have left it very limited, and I didn't see why we should leave it there. It actually strikes me that we should start considering what an IoT architecture and an IoT threat model would be, something a much higher level. But the question is, where would these end? Because those could be massive documents. Next slide, please. So ENISA did produce this IoT best practices document, and that covers a lot of this, this space. And ARM's PSA documents cover a lot of the device side architecture for doing this kind of security. Michael.
Surprise, Mike. Come on. I didn't want to interrupt you here. I wanted to speak at the end of your slide. Sorry.
Okay, cool. I'll keep going then. Next slide, please. What I've realized, though, is that we can't do a top-down structure. And I don't think it makes sense to define an architecture and then define a threat model and then define mitigations, because each architectural element adds new threats, and each threat adds new mitigations, and each mitigation adds new elements in the architecture. So we're going to end up with, if we go through this, it will end up with 3 tightly coupled documents. And they'll all have, it'll be a cluster. That's all there is to it. I think they all have to be developed together. Next slide, please. Now, that being said, I think that this would end up being something very hierarchical. So there are many security area working groups that are already working in parts of these problems. There are some architectures and some threat models in many of the different IoT working groups. And I don't think we need to reproduce any of that work. I think it just needs to be referenced. So this would be an opportunity for us in IoT Ops to draw out cross-standard considerations and to draw out any useful combinations of standards. And one of the interesting examples of this would be when you combine CORIM, SUIT, and RATS together all in one group. That allows a the information, the reference integrity manifest, the CORIM, to be delivered to a verifier signed by the firmware author, so that when it gets an attestation report, it already has the verification information to verify it. And that's a really interesting, more than the sum of its parts kind of situation. Next slide, please. I think that we could have an opportunity here to describe relationships between entities from different standards. There's a lot of places where standards leave things open-ended. They don't describe relationships. They leave things up to the implementer. But there's this overarching view that many of us have about where these relationships should be described and what kind of implementations should be used by an implementer, but this isn't really documented a lot of the time. I think that we have an opportunity there to explain exactly how many of these standards should be used together. And as I previously gave you the example, firmware details provided to attestation verifiers is a good example of this. Next slide, please. Now, there's a couple of different IoT architectures that we probably will have to describe. So you have the centralized architectures where you have one authority or a group of authorities, and communication passes via those authorities or their delegates. Or alternatively, you have peer-to-peer architectures that are decentralized and don't have authorities. Now, that's a very wide separation. Next slide, please. So I don't think that most of them will end up being that extreme. I think that will primarily have hybrid architectures. So we have to describe essentially where the benefits and drawbacks are in the architectures for these different modes of hybrid construction. Next slide, please. That's it. Okay, I did it fast so we'd have time for discussion.
Which is great. So, Michael, you're first in line.
Hi, Michael Richardson. So actually, so I had a thought sitting here that Brendan, with the same slides and the same words, had it been Ted Lemon or Lorenzo speaking to us, that we would understand everything very differently. And Brendan has a very security and attestation point of view. But if it was Lorenzo speaking to us, we would understand this was about IPv6 connectivity. And yet you could have used the same slides and the same words and all this stuff and the architectures and the mitigations and all this kind of stuff. And that's kind of what I wanted to say back at the Tableau thing was I quipped that all the examples were IPv4, and someone said, well, that's actually because operational plants really are lost in IPv4. But a thing I wanted to say then, and I think I want to say now again, is that none of those layers of firewalling were ever designed as firewalls. Those were all designed as NAT44s because there was no architecture that allowed anybody to plug new pieces of network into the existing network. And of course, we designed it all into IPv6. Ted's doing some lovely work with stub networking. And the reason I mention this is that you can't really talk about decentralized communication until you have communication. And you can't really add all those devices intelligently and routers and stuff until you have the security to back them. And so we've actually got the same problem that your diagram of mitigations and architectures, that's not just a security diagram. It's actually an IETF-wide diagram. And the problems we have in IoT is that we're basically, got our fingers in 27 different camps at the same time trying to integrate it. And the reason why Tableau, for instance, is either very wishful or very enlightened, is because effectively we need to, as I think Elliot said, we need to actually be able to map all of those things together. And so while I'm trying not to boil the ocean here, I actually think that there's some things that we can say involving security and networking and connectivity at the same time, and things that we can say, well, you should do it this way. Like that Tableau backbone, honestly, should be IPv6, and all the pieces plugged into it should be NAT64, okay, because they are living in v4 space. And that's actually an architecture that I would propose, and it actually has really good security properties that I think are relevant to things. And so I'm excited about this, and I think that we want to go ahead with what you just said. I'm very enthusiastic. I guess I don't have any questions for you. I just wanted to extend that view a little bit. Elliot's probably got to figure out the part that I missed.
Okay, exactly. But before I give Elliot the mic, so I want to highlight that the chat has a corresponding discussion that's not directly always tied into what you just said, but maybe have a look at that. And Elliot, now the mic is yours.
Thank you, Hank. Okay, so Brendan. No, Michael, I'm not going to say. I'm actually going to slightly disagree with both of you. In that, quite honestly, I liked what you did, Brendan. It basically showed how all the parts fit together in your initial draft. I thought that was a very good start, and I think you're overthinking it. I think actually just getting that far is a win. Now, if you want to restructure how you think about it, I don't mind, but just having sort of a nice view that you presented 2 IETFs ago, as I said to you, I think on both then and on a call afterwards, I think that's a substantial advance. So I don't want to get mired in overthinking the way. If you want to present this in a different way, I'm all for it, but you have a good starting point and we should go with that. And if you want to restructure the starting point, I'm okay with that. But I'm not, I'll tell you what, it would be a shame if we lost that view that you presented.
Okay.
And that's all I wanted to say.
So the other thing, if I'm not mistaken, Brandon, you wanted to see if there are some people who would like to help you out with this.
Well, I mean, if this is something that the working group is actually interested in, then yeah, absolutely. It's a big undertaking. I don't think I can do this myself. Uh, but that being said, if this isn't something that the working group's interested in, then that's fine. And I guess to Elliot's point, I don't see a reason that we couldn't, progress the work that I had done. It's just that when I tried to restructure it into, to explain why I was putting things together, the why led to a threat model, and the threat model pointed to a missing architecture, and that sort of did mire me. He had essentially mentioned that what he'd like was essentially a table of the things that could go wrong and how these different combinations of technologies fixed them. And that is a threat model, right? That's a threat model and an information model. So I was attempting to put that all together, and that sort of pointed me to this bigger question.
So this is Henk before Karl-Heinz and Thomas get on. We have like 3.5 minutes left, and that's, I think, good enough. I agree with Elliot that the first draft of yours is like the cornerstone, and I have to, unfortunately, to agree. A frosting of a threat model and a requirement set about it is required for initial work, but you don't have to again take all of it in, because there was also mentioning like the PLC has the same problem. So maybe scope it to what you just had, add a very specific type of threat model and requirements to that. And I think that is already a big scope. So maybe do not exceed that. And now I'm giving mic to Karl-Heinz.
Just a comment from my part, as far as I understood everything right. I had the imposition, so to speak, to actually go through different standards like ISO 27001, IEC 62443, BSI Grundschutz, and IT Sicherheitskatalog, which is also relevant in German, to put all the security measures together which are needed for an industrial control system. And it was the worst kind of work I ever have to do, and it was quite annoying. So everything which kind of aggregates stuff into something that can be evaluated, and does relieve me from these kinds of work, I think is a good step forward.
It sounds almost like you've done this before and you'd like to help.
I can at least I have a document that's published which actually does the comparison of these things, so we can actually look into it and see if it's valuable in any case.
That sounds great. Yeah, let's get together on the list or bi-directionally, but I will give Thomas the mic now.
Yeah, Thomas Eckert again. So I hope I have some fun closing remarks. Rant. So I think we're playing here in the IETF for decades some Harry Potter game around Voldemort. Don't name the name. And it's the firewall, right? So, I mean, we've seen one presentation here today about what I think ultimately will turn out to be some form of distributed firewall architecture. This one, I think, has, security functions for filtering in the network. Firewall, Voldemort, right? Written all over it as part of the architecture. We have done great work on, let's say, the whole MUD stuff, right? How do I know what a firewall should do? And I was asked to review performance measurements for security gateways, right? It's not called firewall. So, but I mean, we're not having an architecture. We're not, openly admitting that there is Voldemort. Firewall, right? So, what's the strategy of dealing with these things? Do we want to continue kind of just trying to scrap some bits and pieces on every edge, or in IoT they're just front and center everywhere in these networks, and a lot of it very useful, a lot probably very painful. So I think it's, you know, in whatever shape or form we do it, I think it's that particular type of middle block function is really front and center for something like Iotops. I don't know exactly how to answer to it, but doing it indirectly, just as a side topic through an arbitrary set of documents may not be sufficient enough, right? So, you know, firewalls in IoT, right? So what's kind of the IETF's position on that, maybe?
So what
Okay,
I
I
hear
have an answer for that if we have
Okay.
time.
Yeah.
My answer would be essentially that you're absolutely right. We definitely need to focus on the firewall for a portion of the problem, and that portion is probably exactly as it relates to MUD. MUD is absolutely dynamic firewall configuration, probably also dynamic layer 3 switch configuration, but that's maybe less relevant
Yeah.
in wireless networks.
So we can't make this a dialogue anymore because we are minus 1 minute. But what I hear is a quick draft that says, why is this a firewall? Might be useful to get, yeah, ha ha ha. So sorry for breaking this up. I think it's a great discussion, guys. There's this list, IoTops at ietf.org. Let's meet all there. We might have an interim. We will plan that. We will give a shout out and
Yeah, and I think it's probably safe to say that we'll spend a bit more time talking on specific deliverables next time.
yes, no, not only next time, but we will mold a deliverable from this. So we heard names, and we make that thing until the next meeting.
Thank you all for coming.
Jinx. I guess that's the thing. This up again, but whoever built this setup, like, let me look at the screen. No, let me look at whatever that is. No, I don't have any concerns about the Google overloads. They already are overloads. That's why. But yeah, but I don't think that.